Hi everyone. In this video, we are going to look at how to do addition and subtractions with fractions, including rational expressions. We have 8 learning objectives, and they all involved in addition and subtraction of fractions. So let's look at them one by one. First, we have this example. We add fractions with the same denominator. And this one is basically very intuitive, very straightforward. When you add 2 fractions with same denominator, basically you just add, actually subtraction is the same. You add or subtract with numerators. 1s plus 3s certainly is 4s. It's just very straightforward. So this equals, you keep the denominator unchanged, just add or subtract using numerators. So this is 4s. And we always simplify our answer. So both sides can be divided by 4. We get 1/2. So this makes sense, right? Now, let's look at the next example, which is a subtraction. And we have same denominator, so we just do the operation using numerators. 8 minus 2, and that is 6, nice. And both numbers can be divided by 3. So we divide by 3 on both sides. Always divided by same number on both sides when you simplify a fraction. So the answer is 2/3. Let's move on to the next page. And this is your first exercise set. All of the answers to exercise questions is in the comment area below the video. Let's look at our example number 2. Now, we still have addition with the same denominator, even though we have negative numbers. It doesn't make any difference in terms of the way we do it. So we still have 10 on the bottom. So -3, you can move -3 to the top, and there's no difference, plus -1. So we learned how to add or subtract negative numbers before. So 10. So I get -4 on the top. And then we simplify it. Both 4 and 10 can be divided by 2. So we divide by 2 on both sides. The final answer is -2/5. -2/5. Now, our next example, addition with mixed numbers, -7 and +5. So we still have the same denominator. So basically, they're same kind of problem. We just add or subtract using numerators. -7 plus 5. So -7 plus 5 is -2. Whenever you add with numbers of different signs, it basically they go in the opposite direction. One is negative, one is positive. As a result, the one with smaller size get canceled. You get the leftover from the one with bigger size. So we get leftover from 7. 7 is negative. That's why leftover is also negative. So now we just divide by 2 on both sides to simplify it. So -1/12. So you can write this negative sign on this in the front. 1/12. So -1/12. Oh, sorry about that. Apparently, this is a silly mistake. So -1/6. And that's our final answer. Okay, now let's move on to the next example. We're going to do some subtractions. Notice that we still have the same denominator. So the result will have same denominator. We just do subtraction using numerators. So 5 minus 7. 5 minus 7 is -2. And 9 is -2. And that's final answer. This is already simplest form. Let's move on to the next page. For second example, now we still have, even though we have both numerators negative, we still have the same denominator. So we operated the same way. We have same denominator in the result. So on the top, -3 minus -5. So minus minus equals plus. 16, -3 plus 5, which is +2. And simplified on both sides, divided by 2, we get 1/8. 1/8 is the final answer. Next example, we are going to add and subtract rational expressions with the same denominator. Basically, this is exactly the same as what we did so far. And we keep the denominator unchanged. We add or subtract using numerators. So the first one equals 10, 3x plus x, which is 4x. So when we add expressions, we add like terms, we combine like terms. 3x, x means 1x, 3 plus 1 is 4, 4x, right? 4x. Say this x, if we take this x as an apple, this is 3 apples plus 1 apple for 4 apples. This is like terms. So we can simplify between 4 and 10, dividing by 2 on both sides, we get 2/5 for the numbers. So 2x over 5. And that is our final answer. And next one, no difference, 3 on the bottom, x plus 1 on the top. And that is our final answer. They cannot be combined. Now, the next one, we got a little bit longer expressions, but we still have the same denominator. So I hope you see all of these examples. Basically, they are just very similar problems. They all have same denominator. We just add numerators together. 7x squared minus 3x plus 1. So it's the plus. So the plus x plus 4. Now we combine like terms. And usually we write our final result in algebraic expression with the one with highest exponent in the front, x squared. So -3x combined with +1x, -3 plus 1 here, hidden 1. We have -2 for x. Then these two numbers are like terms which can be combined. That's +5. So that's our final answer. Now, this is another set of exercise questions. Exercise is super important. Enough exercise is super important in learning mathematics. Now, example 5, we do subtractions of fractions with the same denominator. So basically, the same as in addition. So we get 9 on the bottom, 4n minus -5. So minus -5, and minus equals plus. That's our final answer. These two are not like terms, and they cannot be combined. The last one for the subtraction example, we have a y on the bottom, the same denominator. Now, this one you need to be careful. -5x plus 3, just because we have subtraction here. If you have one number on the top in the second fraction, there's no difference, just minus that. But you have another multi-term, even though we only have 2 multi-term expression, your subtraction is subtract this whole thing. So you cannot write, say, -4x minus 7 on the top. That's going to be wrong. So I'm going to do one more step just to show you. you're supposed to subtract this whole thing on the top because you subtract this whole fraction. Now we can see what's happening here. I copy this again. Minus 5x plus 3. You need to subtract each one inside. Subtract 2x. Now you get minus minus, which is plus. So just be careful. Now final step, we just combine like terms. We still have 8x squared. Now we combine this 2x term, y is -5, the other one is -2. They're both negative, they go in the same direction, and they will add up. So -7x. And these two numbers are also going in the same direction, both positive. So they also add up in the positive direction, that's positive 10. And that's the final answer. Now let's look at addition and subtraction with different denominators. So the basic strategy described here is that since we know how to add or subtract fractions with the same denominator, we want to convert this fraction addition and subtraction problem with different denominators into the ones that have the same denominator, so that we can still do the same thing by adding and subtracting numerators, right? That's a good strategy. So let's look at our first example here. We're going to add these two fractions together with different denominators, right? So we need to make these two denominators the same. So we call it a common denominator. Actually, we need the smallest common denominator. We call it LCD, which is the common multiple, smallest common multiple of these two denominators. And if we don't get smallest common multiple, as long as it's common multiple, it will work. You just need to simplify your final answer further. And to find LCD, I'm going to show you two different ways to do that. Since this is our first example, everybody needs to know how to find LCD. So first one is that if you don't have many numbers, such as in this case, you only have two numbers, you can use this simpler method, and it's effective. Just look at the bigger number, try to find the first multiple of this bigger number, which is also a multiple of the smaller number. So let's say, what are the multiples of 15? Start with 15. Because that's how you get multiples of a number, by multiplying this number by 1, 2, 3, 4, 5, and so on, right? Multiply by 1, you get 15. Multiply by 2, you get 30, right? So we need to check each of these multiples to see if it is also a multiple of the smaller one. Apparently 15 is not a multiple of 12. So we look at the next one. 30 is not a multiple of 12 either. How do you know that? Once this number getting bigger, you do division. 30 divided by 12 is not a whole number, so it is not a multiple of 12. Now, next multiple, when we multiply 15 by 3, we get 45. Apparently, a multiple of 45 is not a multiple of 12. The reason I can tell this really fast is because of this. 12 is even number. Any multiple of even number still an even number. This is not an even number. So we don't even need to check. So next multiple of 15 by multiplying by 4 is 60. So 60 is even number. We'd better to check, right? So I'm going to use 60 divided by 12. I get a whole number. That's 5 multiples of 12. So 60 is our number. So every number, every denominator should be converted to 60 so that they have common denominator. So let's do that. When you change 12 to 50, I do this one step by step. So which number you multiply 12 to get 50, and you just use this to get 60, I mean. Use 60 divided by 12, and that will give you the number you multiply by. So multiply by 5 on both sides. You have to do it on both sides. See, look at this 5. 5 over 5 is 1. When you multiply anything by 1, you won't change the value, right? We only change the numbers. We don't change the value. Same thing here. From 15 to 60, you need to multiply by 4. So that's how we get the 60 in the first place. 15 multiplied by 4. By 4. Now we get 35 over 60. This one is 8 over 60. And together is 43, right? Final answer is 43 over 60. And this one cannot be simplified because 43 is prime number. Prime number, no other number can divide into it except 43. Now, second method to find LCD, even though this is simple, but I like to introduce that so that if you have more numbers on the bottom or you have larger numbers, the second method actually is more efficient. And basically, the second method is that you factor these two methods to these two numbers into prime numbers. So 12 equals 3 times 4. You can factor it any way you want, but in the end, they all become prime numbers. So this is 2 and 2. So 12 equals 3 times 2 times 2. So I'm going to write this as that's 2 squared and 3. That's prime factors of 12. And 15, we do the same way, 3 times 5. Both are prime numbers, and that's it. 15 equals 3 times 5. Now, what is our LCD here? This is how you get LCD. It's very easy. You copy all of these different prime numbers. I have 2, 3, and 5. Different prime numbers. And then after that, you pick the highest exponent for each one. For 2, highest is 2. So that's 2. For 3, highest is 1. This is 1, this is 1. So 5 certainly is 1. So this is your common denominator, smallest. 2 squared is 4. 4 times 5, 20. 20 times 3, 60. So that's another way to find the smallest common multiple, which is called LCD. So now let's move on to our another set of examples. We're going to add, subtract rational expressions with different denominators. So how about this one, 5 and x? So think about that if you use multiples, you cannot use multiples because it's not a number. So we use the second method, factor each one. 5 can only be factored into 5. X can only be factored into x. Guess what? LCD equals you list each factor basically and take the highest exponent for each. We just have 1 for each. So our LCD is 5x. So now we need 5x on the bottom for each. Now, how do you know which one to multiply with? Look at what's missing from the beginning, from the given one. This is 5, it should have 5x. Apparently, you need to multiply x on both sides. So originally, we already have 2x on top. We need to multiply x on both sides. So multiply x on both sides. Same thing here. That originally, we have x over 3. We need to multiply by 5 on both sides to get 5x. Now, both sides, both fractions have 5x on the bottom. We just add numerators. This is 2x squared plus 15. And that is our final answer. Let's do a subtraction example. Now, we have numbers and letters. So if we do the LCD just between the numbers, LCD, so 1 is 8, 1 is 6. So we only have 2 numbers. We can use the first method to get LCD by looking at the multiples of a bigger number. So multiple of 8 is 8, 16, 24, and 30, and so on. Apparently, the 16 is not a multiple of 6, but 24 is. 24 divided by 6 is 4. That's the first number that is a multiple of both. That's common multiple. So 24 is our number. How about x? 1 is x, 1 is x squared. This one has highest exponent. We take this one. So our LCD is 24x squared. And we need 24x squared for each fraction. on the bottom. So 8x, think about that. You need a 24. For the number, you have to multiply by 3, right, to get 24. For x, to get x squared, you have to multiply another x. So multiply another x. Basically, we multiply 3x on both sides. So we have 3, then times 3x. Second one, we have originally 6x squared. We need the 6 to become 24. So we multiply by 4. X squared, we already have square. We don't need to change that. So we just need to multiply by 4 on both sides for the second fraction. Yeah. Now simplify it a little bit. So we got 24x squared on the bottom. This is 9x minus 20. So that's our final answer. That cannot be simplified among the 3 numbers. That's why we use smallest common multiple. Now let's look at examples that we add and subtract mixed numbers. So pay attention to these ones, and we can add or subtract mixed numbers really fast. First of all, when you add mixed numbers, you can always add whole numbers to whole numbers and fractional part to fractional part. You don't need to convert each one into improper fraction, even though that's still going to be okay, but that method is not as efficient. So let's look at this one. 2 plus 3, that's our whole number part, then plus 1/5 plus 2/5, and apparently this is 5 plus 3/5, and that's 5 and 3/5. That's it. So you don't need to convert each one into improper fraction. And if you do that, you need to multiply and add, and you get improper fraction as a result, but you have to convert it back to the mixed number. Why not just do it directly? Mixed number plus mixed number, another mixed number, right? So now let's look at another example. And notice that this one still adding 2 mixed numbers, but with different denominators. So again, you don't have to convert each one into improper fraction. We just need to have a common denominator for the fractional part. So apparently LCD between 3 and 4 is 12. So we need 12 on the bottom for each. From 4 to 12, we need to multiply by 3, right? So we do it on both sides. From 3 to 12, you need to multiply by 4 on both sides. Now we have 5, 9 over 12 plus 4 and 8 over 12. Now we add whole number to whole number. I just said 4, I wrote 5. And 5 plus 4 is 9, 8 plus 9 is 17. So now this one is improper fraction. I need to convert this part to mixed number. So let's do that. 17 over 12, because basically when you convert improper fraction to the mixed number, you do division. And 17 divided by 12, we know there's only 1, 12 in 17, remainder is 5, right? So there's 1 and 5 over 12. Now this is 9, this is a whole number plus whole number, and that is 10 and 5/12. So that's it, that's our final answer. Now let's look at our next example. We are going to subtract with mixed numbers. Now I'm going to show you 2 methods here. That's why it's method 1, later on we have method 2. So we do 2 methods. There's a reason for that. Sometimes the first mixed number is bigger than the second one. Sometimes it's smaller than the second one. Or sometimes you have negative mixed numbers. So when the first number is bigger than the second one, especially when you have positive numbers, you can still use whole number minus whole number, fractional number minus fractional number. And that way, you can also convert it to the improper fraction for each and then do subtraction. And I'm going to show you both methods and you make decision which one you feel more comfortable with and you stick with that one. Either one is okay. So now I'm going to, since the first number is bigger than the second one, because it's 7 something, this is only 2 something. Certainly this one is bigger. So first method, I'm going to just use a whole number minus whole number, fractional part minus fractional part. Let's see how to do that. They have different denominators. We need LCD first. So LCD between 4 and 6 is 12. This is an easy one, so I'm not going to go into details to do the LCD. So it goes like this. Equals, we need 12 on the bottom, 4 has to times 3, right? Times 3. And 6 to 12, we multiply by 2 on both sides. Now we have 7, 3 over 12 minus 4, 10 over 12. Notice that 3 is smaller than 10, right? So when you do subtraction, you don't want to get -7. That is not wrong, but this is part of the positive number. You don't want the number to have positive sign, negative sign at the same time. This is one number actually. So the way we handle this is that whenever this first numerator is smaller than the second one, after you have the common denominator, you borrow 1 from here. So when you borrow 1, that 1, so let me write this here in detail. So this is a set, I rewrite it 7 as 6 plus 1. You know that's correct, right? And plus 3 12ths. So let me just do it in one more step to see the mechanism. After you understand it, you don't need this step. Now this is original 7 and 3 12ths. So that makes sense, right? Now rewrite this 1 as 12 over 12 because you need this 12 as common denominator. Now, even though you see multi-steps here, more steps, this is for understanding only. Once you understand it, this can go very fast. So apparently these two have common denominator. We can add these two together. 6 15ths or 15 over 12 minus 2 10 over 12. Now take a look at it. This numerator is bigger than the second one. You can use the whole number minus whole number, fractional part minus fractional part now. And we get 6 minus 4, and then minus 2, that's 4. 15 minus 10, that's 5. And that's our final answer. So after you understand this mechanism, you don't need to have these 2 steps. You just go from here. How do we get 15? Because we add this 12 to 3, right? Basically, when you borrow 1, you just add this numerator, whatever it is, to the numerator. That's 15 over 12. You go from here to here directly. That's pretty fast, actually. And after you do some exercise, you can also save this step because you need the 12 on the bottom. You just multiply by 3 on both sides. You go from here to here, actually. So from here to here to here to here. It's pretty fast. You just take a little bit of exercise to understand how this works. Now let's do the second method. Notice that they are exactly the same. So I'm going to convert this one to improper fraction first. 7 1/4 minus 2 and 5 6. So multiply, add. That's how. But eventually, we still need to have improper fraction. Okay, this is the 29 over 4 minus multiply and add 12 plus 5, that's 17. Now we need a common denominator, which is 12. So both sides multiply by 3 in this case, and both sides multiply by 2. Right? Yeah. Okay, now I got 12 on the bottom. And 29 minus 29 multiplied by 3 is 87. minus 34. So 87 minus 34, that's 50. That's 53. 53 over 12. 12. Now let's use the 53 divided by 12 to get 4 on the top. And that's 48. Remainder is 5, right? So 4 and 5 over 12. And that is the same thing. But the advantage of this method is that you don't need to deal with larger numbers in your calculation. You don't need to convert it back to input or to mixed number either by doing the division. It's up to you which number, which method you use. Okay, another set of exercise questions. Now let's look at how to add and subtract negative mixed numbers. Basically, there's no huge difference. And equals minus minus equals plus, right? Now, for this, when you have one negative number, one positive number, usually we want to convert it to improper fraction. And that's not easy to make mistake if we convert it to improper fraction. So multiply and add. Don't multiply -9, okay? Negative this whole thing, convert this whole thing into improper fraction. So negative 55 over 6 plus 3 on the bottom. We need 6 on in the end, 7. So 6 is multiple of 3. So we just need to change 3 to 6. Let's go here. Negative 55 over 6 plus 6, 14, right? Both sides multiplied by 2. Now, since they have same denominator, we can add them together. Negative 55 plus 14. And that is negative 41. Just take 14 away from 55 and get leftover from 55, which is 41, negative 41. So convert this back to mixed number. 41 divided by 6, that's 6 is 36. Remainder is 5. So negative 6, 5 over 6. And that is our final answer. Now let's look at equation examples. Basically, still addition, subtraction with fractions. So to solve for x, we need x on one side by itself. We don't need 3s on the left-hand side, so we just move it. Whenever you move a term to the other side of the equation, change the sign to the opposite. Okay. Now we just have a subtraction with different denominators. The common denominator between 6 and 8 is 24. Again, you do multiples of 8 until you find a number that is also a multiple of 6. So that's 24. 24 on the bottom. So we have to multiply by 4 to get 24. So multiply by 4 on both sides. That's 20. And we need to multiply by 3 on both sides. Okay, 9. 20 minus 9, 11. So 11 over 24. This one cannot be simplified. So that's our final answer. So let's check, let's solve and check, right? At least we do it once. So let's say we get x equals 11 over 24. We add 3s. If our answer is correct, we should get 5, 6, right? Okay, let's check. And we only need to change 8 to 24. Multiply by 3 on both sides, that's 9. So we get 20 over 24, and both can be divided by 4. So we get 5, 6. That is correct. So we get correct answer. Finally, our last learning objective. Let's look at an example of application problems. In the poll, 1/4 of the respondents said that they agreed with the passing of a certain bill. 1/5 said that they disagreed, and the rest said they had no opinion. What fraction of the respondents had no opinion? First of all, when we deal with fractions, the whole thing is always represented by 1. 1 represents the whole thing. For example, 1/4 really means you divide the whole thing into 4 equal parts, you take 1 part. So what is a 4/4? That's whole thing, right? You divide the whole thing into 4 parts, you take 4 parts, that's whole thing. 4 divided by 4 is 1. So 1 always represents the whole thing. So among the whole thing, which is all of those respondents, 1/4 agreed, 1/5 disagreed. And the rest has to be those that had no opinion, right? Yeah, you can only have 3 different responses, right? Either agree or disagree or has no opinion. So basically, these 3 fractions add together will be the whole thing. So our equation is 1/4 plus 1/5 plus the fraction that represent those who had no opinion, which is x, because we don't know it's as long as in terms of this equation, we don't know it for the moment, we will know it later on after we solve the equation. This equal to 1, equal to the whole thing. In terms of whole thing, 1 represents, in terms of fractions, 1 represents the whole thing. So basically, we just need to move these 2 numbers to the other side to get x on one side by itself. 1 minus 1/4 minus 1/5. Whenever we move a term to the other side, change the sign to the opposite. Apparently, we need a common denominator between 4 and 5, which is 20. So LCD equals 20. And x equals 1 is 20 over 20 minus 5 over 20 minus 4 over 20. Now they all have same denominator, 20 minus 5 minus 4. So that's 11 over 20. So 11/20 of all of the respondents had no opinion. So that's our final example. And this is your final exercise. And that is all for this video. See you in the next one.